Hello students, this is Neha Mathur and today from this lecture we are going to start a question bank kind of solution for all of you. All those questions I am going to share over here is from the previous papers, from the previous year question papers of GATE examination as well as NET examination. So for the first lecture I am going to start a subject with digital electronics, and since number system is a very first topic from digital electronics, so from today we will start some questions based on number system. If you want to go through from the basics of number system, then I have a complete detailed video and the link is mentioned over here. You can follow that proper video for the just for the clearance of the basics of number system. After that I will suggest you that once you are able or confident with the theoretical part of number system, after that you should go with all those questions. Here I will try my best to provide the simplest as well as shortest trick to solve all such questions. So now I am going to start. I am again repeating that all those questions are from the previous year examination. So now we will start. If you are, and one more thing, if you are following my content, then consider to subscribe my channel and click on bell icon to get updated for the upcoming videos. So from today we will start number system, and the first question from number system is, see, BCD code for decimal number 874 is, so examiner want to know that what will be the BCD code for the given number 874. So the first important thing is that here the given number is 874 and you need to find out the BCD code representation for that given number. The first important thing is, what is the meaning of BCD? So BCD is basically binary coded decimal, which means you need to convert 4-bit equivalent representation of each digit in binary form. This is a simple meaning of BCD, that BCD means you will have to convert each digit, means here you have total 3 digits. So you will have to find 4-bit representation for 8 as well as for 7 and then for 4. After finding the individual 4-bit representation of each digit, you can just combine them and that will be your answer. Just an example, if you want to find the BCD representation of that very first digit, which is 8 is, so you can take help for the short trick method, which is 8421. A simple method to find the 4-bit representation is 8421. Now for the 8, you have a 4-bit binary representation is 1000. With the help of that coding, I am able to find the 4-bit representation for 8, which is 1000. Similarly, you want to find the 4-bit representation for 7. Then what will be the solution? Again, you should take help from this code, and for the 7, your 4-bit representation will be 0111. 4, 5, 6, 4 plus 2 plus 1, that will be 7. So for the 7, your representation will be like this. And for the last digit, which is your which is 4. So for the 4, you can directly see from over here that 0100 is going to be a 4-bit representation for the 4. So just combine all the digits, which is 1 000 0 111 0100. So this is your correct answer. A is a correct answer. I am again repeating that if you want to find the BCD code for any given number in that situation, you will have to just find the 4-bit equivalent representation for each digit. Here you have total 3 digits. So you will have to find 4-bit binary representation for 8 as well as for 7 and then for 4. And just by combining them, you can find your proper answer. This is the simple method to find the BCD representation for any given number, and that given number may be of 1 bit, 2 bit, 3 bit, 4 bit, or any kind of number it may be. So just remember, for the calculation of the 4-bit equivalent representation, you should remember that a simple funda which is 8421. By using this simple coding 8421, you can find your 4-bit representation, and this will be the solution for a given question. Fine. So now come with the next question, and the next question is 4-bit 2's complement representation of a decimal number is 1000, and you need to find that particular number for which you have a 2's complement which is 1000. So I hope you are getting the question that you need to find that particular number which is, let us consider, which is x, and for that 2's complement is already mentioned which is 1000. So you need to find what will be the value of x. See, the important thing is, the first thing is, here you have 4 options. I will suggest you that you should pick options first. After that you should try to solve that question. Just an example, if I am taking a which is 8 plus 8, and you want to check is it a correct solution for this question or not. For that, firstly you will have to find the 4-bit representation of 8 which is 1000. How I find this? I find this with the help of 8421 coding. After that, find out 1's complement for this, which will be 0111, because 1's complement is nothing but the inverted form of a given binary number. For the 1's complement will be 0, and for the 0, 1's complement will be 2. Now the next is that you need to find the 2's complement, and the method for finding the 2's complement is just by adding 1 in a given number, you can find 2's complement. Fine. So 1 plus 1 0, carry will be 1. 1 plus 1 0, here again carry will be 1. 1 plus 1 0, and carry will be 1. 0 plus 1 will be 1. So 1000 is going to be that particular 2's complement of a given number. And as we are solving this question with the help of options, so it is clear that option A may be correct, because we are taking 8 as an option, as a first option, and we found that our answer is 1000, which is already mentioned in the given question. But the thing is that D is also come in the form of 8. Now confusion arises that what will be the correct solution, whether it will be plus 8 or minus 8, because if you are taking minus 8 over here, which means you are going to deal with this option, then again the process to find the 2's complement will be same, and your answer again will be 1000. So what will be the correct solution, A or D? So in that situation, the simple and the basic concept is that 2's complement is always used to represent negative numbers. So a plus 8 can never be possible to represent in the form of 1000. So definitely the correct answer is minus 8. And now we'll never go with B and C option, because we are already able to find the solution with the help of this number 8 over here. Fine. So keep in mind that this you need to solve such kind of questions in a reverse manner, because if you have an options, then I will suggest you that firstly pick a particular option and then try to solve that question. It is going to be easy method compared to the proper process. Fine. So I am again repeating, remember that you are just taking you just want to find that particular number, and let us consider that the number is x, and if the 2's complement of that given number is 1000, which is mentioned in the question, that means your answer will be correct. And for that I just pick 8, let us 8 as a number. I find binary representation of that number, which is 1000. How I find this? Using 8421. After that, since I want to calculate 2's complement, but 2's complement can never be calculated without the help of 1's complement. So firstly, I need to convert that 1000 into 1's complement, which is 1,000,000. After that, you can find your 2's complement, and the proper process for the calculation of the 2's complement is just by adding 1 in a 1's complement, you can find your 2's complement. So this will be your answer, which is already mentioned. So this is the proper process to find the particular given number if you have a 2's complement given in the question. Fine. I hope you are getting my point. Now come with the next question. And the next question is, gray code for binary number is this. That means you need to find gray code for a given binary number this. So you have a binary number which is 1, 0, 1, 0, 1, 1. It's a 6-bit binary number, and you need to find gray code for that binary number. Fine. So the important thing is, firstly, the thing is what is gray code and what is the binary number. So binary number is just a binary equivalent representation of a given number, which is already mentioned. And since you want to find the gray code, which is nothing but the XOR operation of two binary digits, you only need to keep in mind what will be the process to find the gray code. So I am going to represent it over here. Firstly, I will suggest you that here you have total 6 digits. So since this is your first question, so I will firstly I will recommend you to follow this step. After that, you can make it in a short form. This is your binary number. So I think you should write it like this. This is your first digit. So you can write it like binary digit 0. Just for your just to make your concepts more simple, I am doing this in a proper manner. Otherwise, you can follow simple short tricks once you will be able to solve such questions. But for the initial level, I will suggest you that just go through the detailed process. Fine. So this is a given binary number, and you want to convert that number in a gray code. So what will be the process? See, the first number is going to be, or I can say that first number is written as it is, which is your 1. After that, you need to find XOR of two adjacent numbers. Just an example. Now to find what will be the next step over here, what will be the next number over here, you need to find the gray code for the XOR operation of these two adjacent digits. You have two digits 1 and 0, and you need to find the XOR operation for that. And what will be the XOR operation? For the binary numbers, you are already familiar that the XOR operation is A B bar plus A bar B. Let us consider here A is the first digit and B is the second digit. So what will be the answer? A multiplied by 0 bar plus 1 bar multiplied by 0. So what will be the solution? 1 into 1 plus 0 into 0, which is going to be 1 plus 0 is equals to 1. So here you will get 1 again. Now what will be the next bit? Again you will have to go with the XOR operation of next two digits, which is again 0 and 1, and you can find over here that 0 and 1, which means this operation is going to be repeat again, and you will get 1 again over here. After that, you have again 1 and 0, combination of two digits 1 and 0, and when you are going to find the XOR of these two, you will again get 1 because this is again a repeated process. After that, you have 0 1, again you have a repeated process, so you can directly write 1 over here. The next two adjacent digits are 1 1. So now you need to find the XOR for these two 1 1. So what will be the process? 1 multiplied by 1 ka bar plus 1 bar multiplied by 1. So it will be 1 multiplied by 0 plus 0 multiplied by 1. So it will be 0 plus 0 is equals to 0. So you will get 0. Fine. So your answer will be 1, 1, 1, 1, 1, 0. This is the gray code representation of a given binary number. So your correct answer is D. I am again repeating simple method, the simple process that you have a given binary number. The first digit you can write directly. After that, to get the next bit, you will have to go with the XOR operation of two adjacent digits. And for the 1 and 0, you have a XORing output 1. Now again come with the XOR of next two, you will get again 1. After that come with this, you will get 1. After that you will come with this, you will get 1, and then 1 and 1, you will get 0. So once you will be confident with the concept of this conversion, no need to go with the complete process, no need to write in such a manner, you will be confident and then you can find your answer directly. So this will be your answer. Fine. Now the next question is gray code of A516 is equivalent to. Now see, you have a given number A5 having base 16 and examiner want to know what will be the gray code for that. See, the important thing is firstly you need to find binary representation of that given number. Only after that you can calculate gray code for that. So for A you need to find binary representation, as well as for 5 you need to find binary representation. And what will be the solution? You can calculate that binary representation with the help of 8421. So A is nothing but 10. You can write A in the form of 10, and by using 8421 you can get 1010 is a proper method to write A in the form of binary representation, as well as for 5 you can write 0101. So for A5 the binary representation is 10100101. This is a given binary number. Now the question is completely similar with the previous question. In the previous question you have a given binary number and then you need to calculate gray code. Similarly in this question you have a hexadecimal number, but you can convert that hexadecimal number into binary form. Now you can easily convert that particular binary number into gray code. And for that, what will be the process? Simple process. The first bit you can write directly. After that you need to go with the XORing of two adjacent numbers. Just like firstly you need to go with the XOR of 1 and 0. These two digits are adjacent digits. After that these two digits, then these two, these two, these two, and these two, and last these two. This will be your answer. So first digit I can write directly. After that two adjacent digits are 1 and 0. And what will be the XORing of that? It will be 1 multiplied by 0 ka bar plus 1 ka bar multiplied by 0. So it will be 1 multiplied by 1 plus 0 multiplied by 0, and it will be 1 plus 0 is equals to 0, is equals to 1. So again you will get from here 1. After that next two adjacent digits are 0, 1, again 0, 1. So you will get again 1. I can write directly. Next two digits 1, 0. Again you will get 1. Then next two digits 0, 0. So now the next two digits are next two adjacent digits. For you want to find the XORing operation is 0, 0. And for the 0, 0, what will be the XOR operation? If you have two bits 0 and 0 and you want to find the XOR operation, the process is A bar B plus AB bar. Fine. A and B both are 0. So it will be 0 bar multiplied by 0 plus 0 multiplied by 0 bar. So 1 multiplied by 0 plus 0 multiplied by 1, and you will have 0. So For these 2 bits, we will have a solution 0. After that, the next 2 adjacent bits are 0, 1. We are already familiar with the solution. If we have 2 bits 0 and 1, then the solution will be 1. So you can write directly 1 over here. And for the last digit, which is again 0, 1, we have a solution 1. So you can write directly over here. So I am again repeating that to find the gray coding for a given binary number, you can write your 1. The first digit you can write directly. After that, you need to go with the XOR operation of the 2 relevant 2 adjacent bits. And here 10 can be treated as an adjacent digit. Similarly, for the next 2 digits. So this will be your solution 11110111. I think there is some confusion in the options. So according to me, there is some mistake in the option. So this will be your correct answer. This is not mentioned in the option. No need to worry. This will be your correct answer. Please write it over here by mentioning option E, which is this one. So this is your correct answer. Fine. So you can see that questions 3rd and question 4th both are coming from the same concept. Only the thing is that in this question binary form is already given, while in this question firstly you need to find the binary representation of a given hexadecimal equivalent number system. So here you must have idea about the conversion of how we can convert hexadecimal number system into binary. If you are able to convert that particular number into binary form, then only you will be able to apply gray code conversion. Fine. So 4th question is combining 2 concepts, and 3rd question is just want to find, in the 3rd question we just want to find we can directly apply the conversion over here. So this is about the 4th question. Now the next question is octal equivalent of hexadecimal number. You have a number which is AB dot CD having base 16, because this is a hexadecimal number system, and examiner wants that you need to convert that number into octal. Fine. So what will be the solution? See, this conversion can be executed with the help of 2 steps. Firstly, you need to convert hexadecimal number into binary form, and after that binary to octal. So firstly you need to convert that given hexadecimal number system into binary form, and after that binary form is going to be converted into octal form. Fine. So we'll solve that question step by step. As mentioned in the first step, that you have a number A B dot CD. Firstly find what will be the binary representation of that number. Fine. So as you already know that A can be written in the decimal form as a 10, B can be written as an 11, C can be written as in 12, and D can be written as in 13 in the decimal number representation. Now the next is what will be the binary equivalent for all these individual digits, and for that you can simply apply 8421. For this 10, using 8421 concept, we can find that 8 plus 2 is going to provide you 10. So 1010 is the binary representation for the A. Similarly for 11, when I am going to add 8 plus 2 plus 1, then I will get 11. So I can write that 1011 is the binary representation for 11. After that I will apply, I am going to copy this decimal over here. For C, I can write C as a 12, and I will find 12 with the help of 8421 when I am going to add 8 plus 4 only. So the binary representation will be 1100. And the last one is this D, which is in the form of 13, and I can find it when I am going to add 8 plus 4 plus 1. So I will get 1101 from here. So this is a simply binary representation of a given hexadecimal number. Now the next is that as per the concept from the second step, you need to convert that number in the octal form. And for that, what will be the process? You will have to make a group of 3 digits, 3 bits, and that group is going to be started by following that particular decimal number. See, as per the second step, I have a given number 1 0 1 0 1 0 1 1 dot 1 1 0 0 1 1 0 1. This is a given binary number. Now, as I told you that you need to make a group of 3 digits. So, you need to make a reference point, which is this decimal point. Now start to make a group of 3 digits by taking it as a reference point. 110 can be treated as a first group, next 011 second group, and 01. Now see, here I have a lack of one digit. I must have a group, since I want to make a group of 3 bits, but here I have only 2 bit. I need one more bit, then I can add 0 as an extra bit to make a group of 3 bits. So this is going to be a complete group of 3 bits. Again, come with the left section, and here by taking this decimal as in 0, I need to make a group of 3 digits, and the group will be 011. The next group will be 101. Again, you can see that I have only 2 bits, 1 and 0, and I need one more bit, so I can add 0 over here. So this will be our third group. So now what you did, you have simply a given binary number, and you need to make a group of 3 bits. If you do not have a decimal in a given number, in that case you need to make a group from right to left. You can make a group from right to left if there is no decimal in a given number system, in a given number. But if you have a decimal in a given number, then you will have to make this decimal as a reference point. Then you will have to deal independently from the left section as well as from the right section. For the right section, you will have to start to make a group from left to right, like this, and if there is a lack of digits, then you can add 0. Similarly, for the left section, you will have to make a group from right to left, like this. And again, if there is a lack of digits, then you can add 0 over here. Now, you have a simple individual group of 3 bits. This is your first group, second group, third group, fourth group, fifth group, and sixth group. Now, I will suggest you to take a help of 4 to 1 coding concept. See, 010, 010, which means only 2 is going to be responsible for the representation. So, I can write here 2 directly. Similarly, for 101, 101, 4 plus 1, 5. The next is 011, which means 2 plus 1, 3. Decimal is going to be take its own place. For 110, I am again writing 4 to 1. For 110, these two are giving their contribution. So 4 plus 2 will be 6. For 011, these two are going to be contribute. So it will be 2 plus 1, 3. And for 010, only 2 is going to be contribute. So 2. So 253.632 is going to be your correct answer, which is in the form of octal number 253.632. 253.632. So B is your correct answer. Find. So go through with the concept of this conversion octal to hexadecimal by following these two steps, hexadecimal to binary and then binary to octal. For the conversion of hexadecimal to binary, you need to find the binary representation of individual digit. So initially we did this. After that, once you are able to find the binary representation, then you can directly convert that binary representation into octal just by making a group of 3 bits like this. So this is your answer. Fine, you can take screenshots for your future reference. I hope you are getting my point. These are just simple question from a simple topic, which is number system. Now in the next video I will again show some more questions from number systems. After that, once we will be able or we will be confident with all the questions from number system, then we'll come with the next topic of digital electronics, and similarly in the same way we will cover all the subjects from electronics and communication engineering, all the questions, all the numericals coming from previous examination in GATE as well as NET. I hope you are following the topic. If you are following, please consider to subscribe my channel and click on bell icon to get updated for the upcoming videos. Thank you.